The question over here is at a distance. You are given two strings, word 1 and word 2, and you have to return the minimum number of operations required to convert this word 1 into word 2. So again, this is the dynamic programming question. When you're doing your conversion of word 1 to word 2, you have three options. So firstly, you insert a character, you delete a character, or you replace a character. And if it's the same, then you don't do anything. So you just like move forward, you don't do anything. So you start by getting MNN, length of word 1, word 2. You assign your DP array to be 0, and now you fill it. So for I in range m plus 1, in this you are filling it to be the value of I. So it will be all the way from the first value, so 0, all the way until the value of m. And you do the same for j as well. So you fill the column value as well. So you fill the first row this way, which is the 0th row technically, and you fill the 0th column this way. So it will be 0 1 2 3 0 1 2 3 all the way until the whatever the length of your word 1 and word 2 is. Then for I in range 1, m plus 1, y1 because you have already filled the 0th one, m plus 1 because it's non-inclusive, so it's exclusive, and that's why you add plus 1. For j in range 1 until n plus 1, if your word is the same, if your character is the same, which means you are not going to do anything, so you will use the diagonal value in this DP array, DP grid. Or else, if it's not the same, then you have three options. Your first option is to delete it, your second option is to insert, or you replace. So when you are adding a 1. Why are you adding a 1? Because you are doing an operation out of these three. So you're adding a 1, which is the cost of this operation, and then you're choosing the minimum because you have to return the minimum number of operations. So you choose the minimum of I minus 1, which is the same column but the row above. Then minimum of j minus 1, which is on the left, or if you replace it, so the diagonal value. Of all these three, you will return the minimum, you add the cost of this operation 1, and you return dp of grid mnn. Now at every point you're only looking at these three operations, so on the left, above, and diagonal. Therefore you don't need to take into account the whole grid because you're never iterating at every point, you're never iterating through the whole grid, you're only looking at the row above us. So instead what we're doing is we are space optimizing it, so we are only keeping track of one DP array. Mn, length of word 1 and 2, DP is list of range n plus 1, so it's pretty much the same thing what we did over here. So it just assigns it 0 1 2 all the way until the value of n. Yn, because this is the smallest one, so this will be our result, right? We have to convert it into word 2, which is of size this. So our return DP array will be of size of word 2, which is n plus 1. Now for I in range m plus 1, now you are keeping a track of the previous variable, because whenever we do any space optimization, which I've explained before, we always lose the diagonal value. We still have the value which is in the row above us, so same column in the row above us, because that value is our existing value pre-calculation. We also have the left value because we have calculated it, it's in the same row, and it's the column before us. But the diagonal value, which was technically the row above, so our left value pre-calculation, this was the diagonal left value, we lose it when we calculate the column right before us. So same row, column right before us when we calculated that value. Pre-calculation is the diagonal left value. Therefore, we take into consideration that and we store it in a previous variable. So right now dp of 0 is stored in the previous variable. Then we reassign previous variable to be this ith value. And then for j in range 1 n plus 1, now in this temporary variable we store this dp of j because we know we are going to recalculate it. If word of I minus 1, word 2 j minus 1, if they're the same, then we take into account the diagonal value. Therefore we say previous, which was the diagonal value. Else dp of j 1 plus, now we have three options. Now we have three options. So firstly we have to calculate, we have to get this value, so dp of I minus 1j. Now this dp of I minus 1j was stored over here, so this temporary value. You can also use temp over here. So this is our I minus 1j because this value dp of j, the one we are calculating, pre-calculation, it is the value that we calculated, so which is I minus 1j. So the value that we calculated for the previous row, so previous iteration of this current row that we are on. Then dp of j minus 1, so this is on the left, so this is same row, previous column. So dp, so this in the 2D grid calculation, this is dp of I and j minus 1, so over here, the second value. And then third is the previous, which is our diagonal value. So we do the same thing what we did over here, and then we reassign this previous to be this temporary value, which is dp of j. So technically what was it? It was dp of I minus 1 j value, right? So dp of I minus 1, so the calculation that we did for the previous row. But when we move to the next iteration, this will also be a previous column. So right now it's dp of I minus 1j, so previous row's calculation and current column. But when we move to the next iteration, technically it becomes j minus 1 because it's the column before. And then we can use this previous value as a diagonal left value. So, and at the end you just return dp of I minus 1.